Hello, everyone. I'm Don Solomon, the Dawn of Everything, and today I will be going over the end of chapter problems for Introduction to Probability Statistics and Random Processes. Um, because math stats was actually very difficult for me in university, and I thought because the programming video I did on Little Quilt did so well, I would do a video here on math stats. Here's the book, by the way. I have some notes on the side to in case I mess up or anything. Um, and I'm just going to discuss the end of chapter problems and go through them and write them out. Let me go ahead and read the first one to you. Suppose the universal set S is defined by S equals 1, 2 through 10. A is 1, 2, 3. B is XS 7. C is 7, 8, 9, 10. Okay. Now, I'm going to assume that you know a little bit about sets if you already are doing this. So we're just going to say the intersection of A, B is 1, 2, 3, 4, 5, 6, 7, and that's it. Next question is A union C minus B. Not intersection, union, I'm sorry. This one's an easy one to solve. That is 1, 8, 9, and 10. Let me do a little explanation. AC is 1, 2, 3, union 7, 8, 9, 10, minus B, and B is 2, 3, 4, 5, 6, 7. And that's how you get 1, 8, 9, 10. Next one is A union B minus C. This one's also very simple. It is 2, 3, and then I'm just going to do this to to 10 here. Go like that, and that shows that this set is 2, 3 all the way to 10. And this one's easy as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is what's not an A minus A. And then intersection with B minus C, which is 2, 3, 4, 5, 6, 7 minus 7, 8, 9, 10, which gives you 4, 5, 6, 7, 8, 9, 10, union with 2, 3, 4, 5, 6. So there you go. D is do A, B, C form a partition of S? That is a no, and it is because 7 is in both B and C. I believe 2, 3 is a partition of A, so there's two reasons that that is a no. Alright, problem 2. Working through real numbers in universal set R, which R stands for real numbers, find each of the following sets. Alright, 6, 8 union 2, 7, which is 2, 8. And then 6, 8 intersect 2, 7 is 6, 7. 1, comma 1 C is a constant. Give me a second, I'm solving this one. That's negative inf 0 U is union 1 comma inf. Ooh. Like that. Okay. And 6, 8 minus 2, 7 is 7, 8. Good. If you have any questions, leave it in the comment and I'll do my best to answer them. By all means, I love the support, and just remember, if you want me to do more of these problems, maybe chapter 3, chapter 2, or go to another book, let me know, and I am always up to the task, and we'll try to help you. So problem 3, for each of the following Venn diagrams, write a set denoted by the shaded area. All right. This one's a little tricky. You have to use De Morgan's law. I assume if you're in statistics 1 or 2, this is a book that can be used in either. You've already have taken discrete math, so you know what De Morgan's law. So using De Morgan's law, we can say that A union B is a intersect A up C U B up C. So that's the first one. This one's easy. B minus C equals B up. I'm sorry. Intersect. My bad there. Up C. These should be little c's to show what it is. Okay. Now, let's do the next one here. A intersect. A intersect C is a union of A intersect B minus C, like that. More like this, actually. You have to make sure to separate them like that. You don't want to get the answer wrong. So that was De Morgan's was A, B. Oh, I didn't show C. That was just A, B, and D. The answer to C is A. I'm trying to look at the book while I type. That's why I missed one. U, A, U, B. There you are. Okay, let's go to question 4. A coin is tossed twice. You have HH, HT, TH, and TT in their elements. Alright, this is super easy. A is equal to H, comma, HT, like that. So it's the set of HH and HT. B equal, this is the next one I'm on. Let me check if I'm still recording. Yep, everything's all good. Once these get harder, you're gonna have to give me a little bit of time. And there we are. And that's for all 3. Let's go on to question 5 here. Let A be 1 to 100. Okay. Irrational is an element of N. Imaginary is an element of N. A, okay. This one's definitely a little more tricky. Instead of alright, A2 is 246 to 100, and A3 is 86, 999. Find A2, A3, A5. Find A2 element of A3, A5. Okay. So this is actually very tough, but A2 is half, so 50. Give me a minute. A3 is pre-store between 3 and 6. Negative one of those pairs has to be. So A3 is not divisible by 3. Hold on, I'm doing it in my head. 1, 2, and 100, that's... Oh, wait a second. A3 is just a third. It would be 33. A4 is 25. It's a fourth. And then A5 is, you guessed it, a fifth. Now, by inclusion, it is 50 plus 33 plus 20 minus 16 minus 10 minus 6 plus 3. So that is, I don't have a calculator on me. Hold on. 74. Yeah, I did my math right. 74. Good. All right. Suppose that A1, A2, A3 is a partition of the universal set S. Let B assume that we know blah blah blah. Find B. All right. That is a super easy problem. It is 10 plus 20 plus 15 equals 45. They make it sound confusing, but don't let it trick you. It's as simple as just adding them all up. When you're dealing with math, sometimes it tries to show you, trick you. A 1, 2, 10 times whatever. Determine whether the set is countable or uncountable. I love these. A lot, actually. These are my favorite types of questions. So, first one is countable. For sure, that's easy. You can determine that. Oh, well, it's part of n, which is just number. So of course it's countable. B is countable. You can do that by B equals union A imaginary plus B square root 2, and that will determine that yes, B is countable. And then under the unions, not the, oh man, I messed up real bad. They're not unions. They're, what do you call them? In calculus, it's imaginary is an element of Q, and imaginary J is a element of Q underneath the two sections. But I'm having a hard time explaining it, but if you know what I'm talking about, then you know what I'm talking about, and it's pretty easy to determine that yes, B is countable. C, on the other hand, it's impossible, because it's definitely uncountable just by looking at it. I don't even have to solve it in any way. You can just look at it and be like, uncountable. All right, question 8. Let A equal 0 and negative 1 over n equal x real numbers. Okay, and define blah, 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 blah. Got it. This is also pretty easy. A little more, these two are a little bit more difficult, but it's still pretty easy. So I'm going to put a u down, but the u is not going to mean the same as it always meant. So we're going to put a equals inf u, nope, u, n equals 1, a n equals bracket 0, 1. Now, the n equals 1 and the inf are on top. So inf is on top of u, n equals 1 is below u. And that is, we're applying L'Hopital's rule here. Basically, you have to prove that an and an plus is a proper subset. And eventually doing a little algebra like n minus 1 divided by n is greater than n divided by n plus 1, you determine that negative n is greater than 0 or equal to 0, which is clearly impossible. Thus, you have to have a union of a and s, and that will lead you to a sequence where a is infinite, and then you have limit n to infinity, 0 n over 1 over n, and then you apply L'Hopital's rule where you get a infinite equals 0, 1. Thus you get this. For these more difficult problems, I have notes that when I did them before this video. This number 9 is almost the similar. We have to prove it by contradiction. So just simple as this. Remember, the infinity is on top, and the n minus 1 is on the bottom here. And then n. Now, these are small n. Remember that? Small n equals 0. Oh, 0. Let me quickly go over this for a second. By proving that 1 divided by n plus 1 is less than n divided by n, this is an obvious proof of contradiction. Alright, 10. In this problem, our goal is to show that the sets that are not in the form of intervals may also be uncountable. In particular, consider the set A is defined by the set of all subsets N. What a mouthful. Okay. This is bijection. We're what, trying to prove this? Okay. Let me basically just read you some notes I have here. So we have 1-to-1 mapping of 2n and c. Note that the two n numbers, natural numbers I should say, n will either appear once or nothing, okay? It won't show up. In the presence of set with 1, the absence of 0. So if we have, 1, 5, 10 or 1, 3, 6, something like that, is a sequence of 1, 0, no. Yeah, let's do 1, 3, 6 would be mapped to 1, 0, 1, 0, 0, 1, 0, 0, 0. And if we order the elements or pre-order the elements before, it's 2 natural number, and bijective mapping f2n it goes to c, thus fx, the function, equals 1 element x, where 1 is 2 element x time, and then where 1 is an indicator. So basically it's it's a 1 or 0 format. So I'm just trying to write it down like this. If you have something like this, 1, and then 1, and then E is going to stand for element, 1, 2, E, X, and then so forth, you will get, in the one that isn't in the bracket, okay, is an indicator showing that it is either 1 or 0, true or false, easy programming thing. And if you continue, it's going to do something very simple, and your answer is fx. Fx is not equal to fx prime, and that solves the problem. Now let's go to B. Once again, this is uncountable, and to prove that this is uncountable, you have to go into binary. And if you have B, let's say X is B1 over 2 plus B2 over 2 plus, and then so on and so forth. Eventually, you'll find a bijective mapping of X as an element of 0, 1. I know it's very confusing, okay? But by dropping the 0 at the beginning of the sequence, there's a bijection between two natural numbers in C. This bijection between C and 0, 1 is given the composition of two bijections is a bijection. So 2n and 0, 1, thus two natural numbers on the interval 0, 1 is uncountable. I hope that made sense to all of you. I know it's a very confusing question. Alright, problem 11. Show a set of 0, 1 is uncountable, that is, you can never provide a list form. Okay. Now, this one's pretty easy. Once again, it's bijective mapping. So suppose that the first few mappings are like 1, that's an arrow, 0, 0, 0, 0, okay, and then 2 is arrow, arrow, 1, 1, 1, 1, 1, okay, something like that. Well, if you go all the way through, you'll create a construct of a new sequence. S is an element of C, of the elements which are the let's say this one and this one, and then if we do third, like, I don't know, this, then what, go something like this. This third one right here would be third, and you go all the way down. Thus interval 1, 0 is uncountable. You can just prove, if you do this 7 times, would prove that it's uncountable. But basically you get the gist. The nth digits are all mapping, so there's no natural number that gets mapped to S, thus you can't do it. Okay, 12. Recall ht to the third concealing the following function defined as blah 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 blah. Okay, this one is actually much easier to follow. Once again, they make it really hard, but it's pretty easy. Determine the domain and codomain. Domain is just h t and then up 3, like that. And then if you know the domain, which you can tell just by looking at it, you can determine the codomain just like that. Now, find the range. Range is super easy. Range of f is just the list of numbers. Okay. X can be all triplets and contain exactly 2 heads. That's what we know about F is 2. If you need what that looks like, it goes like this. Then you go T, then H, T, H, or T, H. Sorry. H, like that. And that is, that's 12. We're making our way through these pretty quickly here. Alright. 2 teams A and B play soccer and are interested in find as S equals ABD. Show that A wins, B shows the outcome, B wins, D shows the outcome, and they draw. Suppose that A wins, PA, B wins, PD, 0, 2, 5. Find the probability of B winning. Find the probability of B gets a draw. Okay. Now. I'm going to write out A, and then I'm not going to write out B. Because I'll show you how to do A, and then I'll just show you the answer to B. Because it's probably easier. So if you go P, B like this, equals 1 minus P A, because we know what A looks like. Oh. Go like this. Minus P D equals 1 minus 0.5 minus 0.25, and if you were counting, that's 0.25. There's your answer for A. For B, very similar problem. We're just going to say that it's 2.5, and let me say it's 0.25 plus 0.25 because you take B and D and just add them together. That's it. I'm not going to do that, but this is B right here. Oh wait, 14. Let A and B be 2 events such that PA for blah, 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 blah. PA is for B7 and 09. Okay. There's a lot of questions here. And I'm just gonna put the answers to each one, because I'm going to assume that you know how to do most of this. Well, I'm not gonna assume that. I'm not gonna just put the answers to each one. I'm gonna put all the numbers. I'm gonna assume how you know to translate the letters to the numbers listed. So let's get right into that. 0.4 minus, plus 0.7 minus 0.9 equals 0.2. Then for B is 0.7 minus 0.2 equals 0.5. 0.4 minus 0.2 equals, you guessed it, 0.2. Now, we're going to get into some of the harder ones here. I recommend drawing a Venn diagram for this one, but you can just do 1 minus 0.9 equals 0.1. And remember, S is the universal set. So when you look at the formula there, for D, you're looking at PAC minus B equals PS, which then negative PAUB, because you're finding the AC there. Okay, now that I have that explained, we'll go to the next one. 1 minus 0.2 equals 0.8, like this. And F is just 0.2. No calculations need to be done, because AUB is an intersect of is a union. A intersect B is a union of A intersect A. C, where A intersect B is union with null, and then it just leaves you with A intersect B, and A intersect B is 0.2. All right. Finally to some probability. Let T be the time needed for the job CERN factory by using historical data. We know that. Okay. First you need to find the first roll, and you need to find the probability of T minus probabilities for all outcomes. And that's a lowercase 2 underneath. Equals 1 out of 6. Then we're gonna do, this is where I'm B now. Then this is a lowercase 1. (36) 1/6, just like that. And then, oh man, 1T3, 1T3. Hold on, I'm doing a list. So let me explain what I'm doing. You take tuples, and you take an event space, which would be 3 times x minus 3 is 15. Okay, you have 15. So px1 is not equal to 2 intersect x2 for, so the answer is 15 over 36, which then can be simplified down to 15 over 12. Okay. We're on night 16? Oh. I'm sorry. Yeah, no, I'm doing this right. Find the probability of x in 4, x in 7. I was reading 18. Ignore my dyslexia. I was reading 18, but I was doing 15. That happens to me a lot. But 15 was, find the probability of x2 equals 4, find the probability of x1 plus x2 is 7, and find the probability of x not 2 is x2 greater or equal to 4. But yeah, you have 1 out of 6, 1 out of 6, and 5 out of 12. Now, 16. PK, C is 3K for K equals 1, 2. Find C, find P2. Oh, jeez. Random experiment. Oh. So you need a geometric series to do this. And it's a pain. It's a real pain. But I will do them for you. Don't say I didn't do anything for you guys. But basically, to simplify it down, we're gonna do 1, 3, 1/3. Okay. Which equals C equaling 2. Wait, no. So C equals 2, like this. That's your answer for A. Then you got to do the same thing here. I'm going to save you the heartache and just tell you that this is 82 over 729. And then this is 109. I mean 1 over 9. Now let me go over these before we move on, because I don't want to type the whole thing out. For B, you take P246 and you take P2 union 4 union 6. Then you add those all together, which gives you 2 1 over 3 2 plus 1 over 3 4 plus 1 over 3 6. That's how I got the 182 over 79. And then for C, you need another geometric series. So after you solve the geometric series, you get negative 2 bracket 13 over 9 plus 2 and then bracket 3 over 2. And if you solve that, you get 109. Now, if you do the geometric series differently than me, you can get an incomplete answer. What I determine is incomplete, but some professors might determine that instead of that being the answer, you can get 1p minus p2. If your professor is looking for that answer, he's a real stickler for answers, and I'm sorry that you have him for a professor. Because that is also correct, but I apologize on behalf of all professors. Okay, we're on 17 here. Let's see. Find the probabilities of each team winning the tournament. Okay. So when you do something like this, you have to think about the question. You have A, B, C, D, right? And you know that the probabilities are required to equal 1, being 100, right? And you know that C wins 0.6% of the time. So you take PA, PB, PC, and PD, and you make a matrix out of them, and you'll get 0, 0, 0, 6, 1. Now, just because the other teams haven't won doesn't mean they can't win. So you take an equal opportunity for the 0 and the other 0. So you would get 0.2. This would all be in a bracket. 0.2, 0.2, 0.4, and 0.2. Now, how did I get these numbers? You make a matrix where they have to equal, well, PA, PB, BC, and then you take the inverse of 1, negative 1, 0, 0, 0, 0, 1, negative 2, 1, 0, 1, 0, 1, 1, 1, 1, 1, which when you do that, right, with 0, 0, 6, 0, 1, you get 2, 1, negative 3, 2, 1, 1, negative 3, 2, negative 2, 1, negative 1, 4, 2, negative 1, negative 1, 2, negative 1, and then you get these numbers. It is very tough, but completely doable when you have time. Here, in this video, I don't want to do it because I want to save you the time, but if you're asked to do it, that's how it is done. All right, 18 like I was is pretty easy, and then the greater equal 1, that's greater sign equal 1 equals 1 over 16. Right. Okay. So this is your answer here. That's pretty easy. And the other probabilities are also very easy just by looking at the graph. So I'm not going to bother going into them, but you got 3, 4, and 1, 2. To solve B, it's 1 minus 4 over 16, which gives you 3 over 4. And for C, it's 9 over 16, and 1 over 16 gives you 1 over 2. All right, 19 is pane. Hold on, let me look at my reference material here. Because I don't remember how. Okay. Yeah. No, right. Standard area shaded. So, do we want what? Choose point randomly. What's the probability of the equation? To find the shaded regions of the following. Oh, this is a real pain. Okay. So, wow. Let me do this. So, first, there's two questions. What is the probability? Well, the probability is 1 for AB less than equal 0, or AB is less than 1 over 4. But now it's asking if there's real solutions. And to get the real solutions, you just have to find the area. And to find the area, it's not that difficult, but you need to know how to use integrals, or integrals, I'm sorry. But for the purposes of this video, I'm just going to tell you what it is, and it's 1 over 4 plus 1 over 4 length 4. Now, I'm going to quickly just go over why this area, what it is. So you take PR in the area of the shaded region over the area of the square, the area of the shaded region over 1, which gives you the area is 1 over 4 plus the integral of 1 over 4, where 1 4x dx is 1 over 4 plus 1 over 4 length x, and 1 is over 1 over 4, which gives you 1 over 4 plus 1 over 4 length 4 is the answer. Okay. Now, we're not done yet. Okay. Because 1 over 4 is not the answer you're looking, is the probability. But that if your professor is easy on you, that's the answer. If it's tough and he wants the exact number, you can always convert 1 over 4 plus 1 over 4 log and log 4 into 0.60. This is the closest number that you can get to this number. That's why, if you are wondering why I would do that, if I was hosting the class, I would always request this 0.60, because if you get 1 over 4 plus 1 over 4 log 4, yeah, you solve the problem, but you know, not the best. Could have did better. Okay. 20. Continue the probability sequence. Yeah. These are proofs, and I'm just going to show you the proof the end of the proof of each one instead of showing you the whole proof, because there's a lot to each one. But I'm just going to show you that it's lm and then n to infinity. Okay, that is an arrow to double is p a and then lower n, and that's the proof of A. And then the proof of B is lm, same thing, infinity, p n. Now a lot of professors will not accept this. I wouldn't, so I'm going to read them to you. PA equals PA1 plus geometric series imaginary 2 and infinity on top, PA negative A subtract A imaginary 1 minus 1. Okay. Now if you're following along, once you have that, you can get PA1 plus lim n to infinity, PA2 minus PA1 plus PA3 minus PA2 plus PA4 plus PA minus PA3, which will get you PA plus lim n to infinity to PAN minus PA1, which then gets you to the answer written here. And I'm going to do the same with 21 and just put the bottom. So n u I equals 1, and then I like that. And then we got to go down. And then if you need the proof, you take this and you copy it. Just do it again. If you want the proof, you take this and you just put lm and inf p, and then you bracket the whole thing. And then if you want proof for B, it's the same as before, but instead of inf B and you go like this, I 1 AI like that, and that will give you the other one. Okay. 22. I know I'm skipping through some of these. Alright, 22 is super easy. It's 0.2 over 0.4 equals 0.5. Now, I love super easy ones because we know that coffee is 0.7 and cake is 0.4. So you take coffee cake on top and you take cake on the bottom. And coffee cake is 0.2. Can't more of them be like that, huh? Now, 23. 23 is also very easy. Like last time, I'm not going to show you all the translations, but basically, to do question 1, you go like this, 0.05, and that equals 0.57, roughly. And then I'm just going to put the answers for the other ones since we're going to be here a while. That's 4.3, 0.36, and 0.5. Okay? And I'm just going to quickly tell you how it is. For B, to get 0.43, you put 0.1 plus 0.05 on top of 0.1 plus 0.1 plus 0.1 plus 0.05. That gives you 0.53. 0.1, I'm on C now. 0.1 plus 0.05 over 0.1 plus 0.2 plus 0.1 plus 0.1 plus 0.5 plus 0.15 gives you 0.36. Then, if you take 0.1 over 0.1 plus 0.1, gives you 0.5 for D. Very easy. Very easy. 25. 600 students, 120 students, and 200 students. Once again, this is easy. So 3 out of 10 for the first one is literally 0.3. 2 out of 5 for the second one would be 0.4. How am I getting these numbers? Well, you have 600, you have 120, and 200. Now, can you take a guess what 200 lived on campus? Well, that would be 4 out of 6, which is 2 out of 3. If you want to solve that in a different way, let's just take B, for example. B would be P. X is less than or equal to 2 dividing line, not divided by, dividing a line, okay? X is less than or equal to 5. And that's how you get 2 over 5. And for the first one, you don't put a dividing line, you put X there, and then you get 3 out of 10. All right. 25. That was 24 I did, and I read 25 because I am a dum-dum. I am a dum-dum. I cannot read. Those are still the... Yeah, those are the... How you do 24. I was reading 25 in the book, but that is how you do 24. Sorry. 25 is 200 over 600 equals 1 over 3. And if you know how to do the other ones, then that's 1 out of 5 and 1 out of 15. Whoops. All the answers are still right, but my explaining was a little off because I was trying to show how the interval. I was saying the interval was these numbers, but I was looking at these. I was looking at 5's numbers and looking at 4's numbers, but 4 is still super easy. I explained it the right way. I just read it wrong. The right way is still 2 and 5 gives you 2 over 5, and 2x 5 is 3 over 10, and 3x 8 x 4 is still 4 over 6 equals 2 3. My bad. And explaining 5, you have 600 students on campus total, so 200 over 600 is 1 over 3. 120 over 600 is 1 over 5, and 80 over 600 is 1 over 15. No, 1 over 5 minus 1 over 80 is 1 over 15. So yeah, those are still the answers to 0 through 25. Okay, so we're on to 26 now. I roll the die n times, n equals n. Find the probability that the numbers 1 and 6 are both observed at least once. Okay. For this, you got to make a tree diagram. So let's say you start with 100. Okay. Or just 1. You put 8 on top and 2 on the bottom. Okay. Yeah, let's do it that way. You have 0.8 on top, 0.2 on the bottom, which leads you to 0.1 and 0.9, which gives 0.08 and 0.72. and then on the bottom you have 0.2 leads to 0.3, which is 0.06, and then on the bottom is 0.7 of the 0.2, which is 0.14. Using those numbers, you get 1 minus 2, 5, up, and minus 4, n over 6. Am I doing that right? Hold on. 1 over 2, 5, 6, and negative 4, no. Minus 4 over 6 and regular. That's the answer. Alright, 27. Complete the following tree diagram. Now, if you were paying attention, the following tree diagram is the same tree diagram that we made in number 26. So I'm just going to read it to you. 1 leads to 0.8 and 0.2. Then from 0.8 you get 0.1 and 0.9. From 0.1 you get 0.08. From 0.9 you get 0.72. That should be your top. From 0.2, which is your bottom now, 0.3 leads to 0.06, and 0.7 leads to 0.14, which is your bottom. Now, I'm going to say B. You should all know how B goes if you have the tree diagram. Like this. And then C is 0.84, like that. Now, how did I get 0.84? Well, I'll show you. 0.72 over 1 over 0.14 equals. Okay. 28. In a factory, there is 100 units. All right, remember, 100 units. 5 is which are defective. Okay. We pick 3 units from the 100 units at random. What is the probability of that exactly one of them is defective? Okay, so let's say you have 100 units. You would take 5 over 100, 95 over 99, 94 over 98, plus 95 over 100, plus 5 over 99, 94 over 98, plus 95 over 100, plus 94 times 99, and 5 over 98. Do you see what I'm doing there? You create 3 sets, right? And then you add them all together, and all the sets have to be equally different. So 5 over 100, and then you have 95, which would be subtracting the 5, over 99, and then 94 over 98, which is minus 1 from 99 and minus 1 from 95. Anyway, if you do all that, you get your answer of 0.14. Dope. Coolio. We have 29. We're getting close to the end here. Reliability. When systems components are connected in a series, system works if all components are functional. Yes, we have diagrams. C minus C2, C3, C... Oh, we just have to put... This is piss easy. Sorry for swearing, but this is super easy. You got P down 1, P2 down to P3 down, okay? And then by inclusion, P1 plus P2 plus P3 minus P1 P2 minus P1 P3 minus P2 P3 plus P1 P2 P3. Good. Then for this one we can do the same thing. P1 P3 plus P2 P3 minus P1 P2 P3. Right. Now C is a little bit tougher, but it's basically P1 P3 plus P2 P3 minus P C1 C2 C3, which gets you what I wrote down there. D is P1 P2 plus P3 minus P1 P2 P3. And for E, we have P1 P2 P5 plus P3. I'm saving you time, and I'm just telling you the answers here, and then I will go over it after. Okay, we are done. Oh, we are not done. My apologies. There's P5. Let's just go over E, because I already know someone's gonna have a problem with me doing E. So you take PF equals P, C1, C2, and C5. Then you add that to C3, C4, and C5. Then you subtract P, C1, C2, C3, C4, C5, and that's how you get the P's. 30. You choose point X, Y uniformly at random in the unit square. Let A be the event. Okay, show sets of A, B in an X and Y plane. I can't really show that off in this video, but what I'm going to say is Y is greater than negative 1, 2 plus X, and Y is less than 1 over 2 plus X. Okay, I'll say that one more time. A is Y that is greater than negative 1/2 plus X. And the bottom of the plane is Y is less than 1 over 2 plus X. Now, as for B, B is pretty easy. You got 1 over 2, and then 1/2, and 1/2, and once again 1/2 equals 3 over 4. So PB in the sequence, or the thing, is 1/2. In C, same sort of thing, do it again, and it's 3 over 8. And the other one is 3 over 8, and both are independent. Okay. Dead. I'm not the... I did programming and math. Let my English go. Okay? English wasn't my favorite. Or my best. Okay. What are we looking at here? We're looking at 31. A, emails open. Ooh. Okay. Right. Okay. Yeah. Let's just... Let's... You know what? I'm going to do the whole thing. And I'm going to show you how it's done. Like this. Okay? And then we will go over it in a second. Now, what did I just write? Well, first, let's read what it says. 50% of emails are spam. 1% contain the word reference. 0.001% contain the word refinance. 1% of spam contains the word refinance. 0.00 contain the word refinance. Okay. Using, what was it called? Bayes' rule. You can put them in this setup where you have half the time 1% of the time and 1% of the time, and that's how you get this. Okay, 32. Oh, I see the end of the page. Well, this is a fun one. Would you like to go from point A to point B? Yes, I would. There are 5 bridges in the way. Find the way, Cape Bridge. Find the way. Okay. So there's 2 parts. Oh no, I'm not going to type this all out. Okay. So I'm not going to check the answer, but you can basically go every way and find the answer. But you take path 1, path 2, path 3, path 4, and let P be the event of the open path, which would be the imaginary open path, where only one path needs to be open for an event A to occur. If this event occurs, the probability of A is P1 or P2 or P3 or P4. Thus, you accumulate all the numbers and you do all the work, which is a big pain, and you can just tell that there are only 2 paths where PA work. And the limit of that, P3 is 0, so we can see that indeed matches the probability. So I'm just going to write this out as this. So if you want PA, the probability of A, you go P1, P4, plus P2, P5, minus P1, P4, P2, P5, and you limit it to P3 equals 0. And there's your formula, and there's your probability. Now, to do the next one, you need to use Bayes' rule. And you obtain the answer, which is a real pain. But luckily, I have it written down here, but I can't copy it. So let me just read it to you. PA-B3 is P1, P4, P3, 1 minus P2, P5 minus P5 minus P2 plus P3, P2, P5 plus P3, P1, P5 plus P3, P2, P4 minus P3, P2, P5 minus P3, P2, P5, P4 plus 2, P1, P2, P3, P4, P5 over P1, P4 bracket 1 minus P2, P5 minus P3, P5 minus P2, P3 bracket plus P2, P5 plus P1, P3, P5 plus P2, P3, P5 minus P2, P5 P1, P3 minus P2, P5, P3, P4 plus 2 P1, P2, P3, P4, P5. Your brain hurt now? That's your answer. I'm not going to write all that out. But, yeah. All right, 33. This one, super easy. You have 1, 2 goat, okay? And the Monty Hall problem, you are in a game show and gives you behind the door, there are 3 goats. No. Others are goats. Okay, so the host actually, do you want to switch? The question is, what's your advantage to switch your choice? This one, you can easily solve it by 1 over 1 over 3 over 1 over 2, 1 over 3, because there's 3 doors. 1 over 3 plus 0 equals 2 over 3. Therefore, in interest to switch the door to 2, the host opens door 3, or switch the door to 3, and the host will open door 2. Alright, 34. You toss a fair dice, which means it's 1 through 6, and there's no cheating, to obtain x and y, so it could be 1 through 6, and let A be the event x is 2, B the event x and y equals 7, and C be the event y is 3. Easy. Easy. Okay. Easy. Are A and B independent? Yes. A and B are indeed independent, because A and B are both fair dice, so you have 1 in 36 chance. Are A and C independent? That is yes. Same as last time. PC is 1 in 6 and AC is 1 in 36. Identical problem. Is B and C independent? That is a yes. B and C is 1 over 36 and BC is 1 over 36. Once again, they're independent. Okay. Are A, B, and C independent? If you wait a second. If you have A, B, C pairwise, you need to check if ABC is ABC, and the probability of P ABC equals 0, since those events cannot occur all at the same time. Thus, A, B, and C cannot equal 0, so the events are no. They are not independent. I tried to trick you on the last one there. Aha. Okay, 35. 35. Magic number. These are the tough ones. You and I play a game, toss a coin repeatedly. Okay, coin problem. Basically, you have to use Bayes' rule, and you get down to 1 over 1 plus Q, which equals 1 over 2 minus P. You can just plug all the elements in. So you take H2 consecutive. Okay, you take P x1 equals HW, P HW1 equals H, P x1 equals H, P W, and you can put that in a little formula. You know what? I'll actually write it down here. This one's a little confusing, so I'll write it down for all of you. So there it is right there. There's your top and your bottom, which gives you 1q, 1 over 1q. So, not that hard. And you just have to do this. Let me read it. A box contains 2 coins, a regular coin and a fake two-headed coin. Oh, the fake coin. Choose a coin at random toss at n times. If the first n toss results in a head, what is the probability the n plus 10th coin toss is the result in heads? Okay, let's say if we use Bayes' rule, we get this. This is honestly a very complicated problem, but and there we are. So there's our answer. You can check the probability if you want. If you want, you can check it by doing this. And that's how, if you feel like it. $37. Another Bayes rule problem. All right. I'm just gonna tell you. This one sucks. No point in trying to hide it. Okay. I'm here to tell you honest. I have a note saying that this took me 2.5 hours. Yeah. So, your professor gives you this problem. I give you permission to tell him that the dawn of everything is gonna come and find him if he gives you that problem. You have my permission, personal guarantee that the dawn's after him. All right, 38 and 39. These ones aren't as bad. 38, you take P, G, G, L like this, which equals 1, comma 1 minus A, up and N. Now that A is an alpha. Keep that in mind. Actually, it's so important. I'm going to write out that these are alphas. Okay? And then you just want to simplify that down all the way down to this. And you get 1/2 minus 1 as your answer. In this case, n equals 2, which is the problem. This is a similar expansion polynomial that was problem 7. I think it was problem 7 in section 1.5. Let me check. Yeah. So you can refer to 1.5 if you need help there. But basically, if you evaluate the formula n equals 21 and find that PGGL is equal to 2 minus a, 4 minus a, which these are alpha, 2 minus alpha, 4 minus alpha, just clarifying. And that's 1 over 2, which is the same formula for section, same formula as the answer to section 1.5 problem 4. And now we have the last one. And the last one is a family of n children. We pick up a random and find out that she is a girl. What is the probability that all their children are girls? Well, what's the probability of boys and girls? 1/2. So, if you have a probability of boys and girls are 1/2, and you say n is what? If you say n is 1, if you say, let's say n equals 1, you can do this 2 different ways. If your professor says n is 1 and clarifies that it has to be n is 1, you can go like this, and you say it's 1/2. If n is 2, your professor says n is 2, then still just as easy, just a little more involved. You go like this. And you get 1/2 twice. Therefore, in this problem, you can say that it is PG G bracket R equals 1/2 up bracket n minus 1. And that's it. That is all 39 problems right here. I'll go ahead and show them to you. This is all 39 of the problems done. If this helped you anyway, please subscribe. And I would really appreciate it. If there's enough support, I could possibly do chapter 2 here. If you guys would be interested in me going through chapter 2, I don't know if I'll go through the whole book, but maybe. But if you want me to go through chapter 2, leave a comment. And yeah. So remember, I'm Don Solomon from the Dawn of Everything, and don't you forget it. Have a good one, everyone.